Cohen kappa to see the agreement between the two instruments. But there is a word caution in there. What is that? Whenever you are just interpreting the result of this Cohen kappa, then you have to be very cautious. Like, just if the value of this kappa is very high, that doesn't mean that both are correct. That doesn't mean that the decision is correct. Why? Because both can be wrong. So this issue of, like, if both rata are inexperienced, or if both are diagnosing or labeling a patient wrong, or misdiagnosing a patient, then you cannot detect this via Cohen kappa. This is one of the limitation of this agreement analysis or the Cohen kappa. So you have to report it whenever, and there are ways also to check this, whether it is by mistake. I mean, both are inexperienced, and there is something we will discuss in the further during the towards the end of this session. There is something known as the prevalence adjusted and bias adjusted kappa. So this prevalence adjusted and bias adjusted kappa also takes this few of this limitation into account. And again, this you have to report that the agreement is high, but still there can be a possibility, because again, this is a limitation of Cohen kappa. So whenever, like I said, that you can, even if you are just guessing randomly, then also you will have some chance factor or the total agreement. So in case of a Cohen kappa, how do we calculate it? We are just showing it with one example. Although with JASP and Jambovi, you will get it automatically calculated. So whenever you are using the Cohen kappa, you first measure the observed agreement and you measure the chance agreement or the expected agreement. And then there is a formula, and you put those values in that formula, and then you divide it. So if you see the observed agreement, what is the observed agreement? Observed agreement is a percentage of cases where both the ratas agree. Like in the previous example of tuberculosis, this one. So this 50 and 85, this is your observed agreement, because on these two, the raters, they agree that these many are the total positive and the total negative. And then there is something known as the expected agreement. So what is the expected agreement? It is the percentage of agreement which would occur by chance. And that we have to see how each rater that is using this category. So this expected agreement, that is, we calculate using this formula, which is in the numerator, we take the proportion of observed agreement and we deduct the chance agreement from this. And in denominator, we again do like 1 minus this chance agreement. So the formula is like this: kappa is P0 minus P0 is your observed agreement. If you see this formula, you don't need to, I mean, just for conceptual thing we are telling, otherwise you get the value of kappa. So this P0 is the observed, this P is your chance agreement or the expected agreement. Similarly, in the denominator, you do 1 minus P expected or the chance agreement. We are using the same example which you have seen in the earlier slides. Like there are 100 patients and Dr. A and Dr. B, they are diagnosing these patients. So 50 and 10, total of 60. So the Dr. A's have said the total cases positive as 60 and Dr. B has said total cases positive as 55. Similarly, Dr. A has said total cases negative as 40, whereas the Dr. B has said total cases as 45. So how do we calculate this? So there is a rule of probability. So we will use that rule here. So in the first step, we calculate the observed agreement. So what is the observed agreement? Observed agreement is these two cells, like where the Dr. A and Dr. B has agreed on both the cases, and then there are like both these negative and negative on these two, like both negative agreement and the positive agreement. So if you see the total, it is 85 by 100, which is 0.85 or 85%. This is your observed agreement. Now, to calculate the expected agreement, there is a use of probability theory. So what is probability theory? So let's understand this with a coin. So if you flip a coin, there will be 50% chance it will be a head, and there will be 50% chance it will be a tail. So if I ask this question, if both the events are independent to each other, and if I ask this question, what is the probability that no, both get heads, both these person get heads, then the probability of getting this person A and B as a in together, that will be your P. Use the multiplication rule. So zero point 0.5 and zero point 0.5, it will be 0.25, which is 25%. So if there are two independent events, and we say that the probability of occurring both the event together is the product of their probability. Using this rule, we calculate the expected probability. So expected probability, if I calculate the expected probability of positive rating. So let's say I am only focusing on positive rating. So TB positive 60, they have 60 out of total. If you see, they have rated it positive. Dr. A and Dr. B have rated total 55 as positive. So both Dr. A and Dr. B, if I have to calculate the expected agreement of positive cases by Dr. A and Dr. B by chance, then it will be like 0.6 multiplied by 0.55, which is 0.33. Similarly, if I have to calculate for negative cases, so this agreement by chance for negative cases, if you see the negative cases, the total negative cases here is the 40. And the total negative cases here is the 45. So these 45 by 100 multiplied by 40 by 100. So this is here, which is 0.18. This is your chance agreement or the expected agreement using for the negative cases. So if I have to calculate both for positive and negative, this 2 gets total. And then your total agreement by chance will be your 0.33 and 0.18. That means these two, this value, and this value, because by chance agreement for positive and by chance agreement for negative. So it will be your total chance agreement, or the PE will be your 0.51 or the 51%. That is your chance agreement. So what was the formula? In numerator and denominator, both in numerator, you do like P0 minus this chance agreement. So we can say, how we will say that? Original, if you see the observed agreement, if you see this one, this was 85%. This was because 50 plus 35, 85%. But if you see the chance agreement was 51%. So how can we say, like, even though the doctor agreed on 85% of cases, 51% could have just happened by chance or the random matching. And for that's why we need to deduct this chance agreement from the numerator, and in denominator, again, it's 1 minus PE. So your overall value of kappa is 0.69. So 0.69, so if we say the true agreement, it is 69.4 and it is not the 85%. So that's why, how do we define kappa? So this kappa is like, what is the total agreement beyond by chance factor? That means even if we remove that chance factor, what is the agreement? And that's how we define the kappa. So up till this level, am I making sense to all of you? Before I go, can I see the chart? Any questions? Okay, so Dr. Ravi has asked one question. Can you put that? Can there be a possibility of bias in kappa? Yes, Dr. Ravi, there are few biases in kappa, and I think I have mentioned one of the bias, like if there is a high or low prevalence, if there is a shifted prevalence of the disease, then this kappa, although the agreement will be high, but the value of kappa will be very low, and we will discuss this in the subsequent, like after, let's say, half an hour. This concept will come. There can be biases in kappa, and there are ways to address that. And one of the scientists, he has written a total, one article based on that. We will share the reference also, and I have put that snip also here in the slides. So Dr. Praveena is asking, please explain this slide again. So this one, Dr. Praveena, this Cohen's kappa one, like this P0 minus expected, you want me to explain? This slide
Ma'am,
means
actually, I don't, ma'am, I'm not very clear about the final statement. Once we account for chance, agreement is around 69%, not 85. I don't understand, ma'am, why that 85 comes here.
okay, so this 85 one actually the observed agreement which we have calculated from here. If you see this is your
Okay, ma'am.
50 and plus 35. Because if you don't calculate kappa, 50 on 50 cases both of them agreed saying yes, and on 35 cases both said no. So the observed agreement will be 50 plus 35 by 100, which is your 0.85. So this we just wanted to show that in the kappa, you just remove this chance factor. And that chance factor is like, even if the rater just rate randomly, then also there is a probability that 51% times there will be agreement. So that's why from 85%, it has gone down. I mean, this chance factor is 85%, sorry, 51%. And that's why we have removed that from the numerator. I mean, deducted that from the numerator and 1 minus the same as a denominator. Did you get it?
Yes, ma'am. Thank you, ma'am.
Okay, you are welcome.
Good afternoon, ma'am. I just had a small question. Good afternoon, ma'am.
Yeah, good afternoon, Shiva.
Is Cohen's kappa calculated only for binary outcomes? Like, do we need to have only two categories, or we can calculate it for more than two categories?
No, you can calculate it for any number of categories, but it should be symmetric. Symmetric means
nominal
like
variable.
Yeah, for nominal variable, first thing is symmetric means like if one rater is rating on 4 category,
Yes,
the
ma'am.
other person should also rate on 4 category.
Okay, but the variable can have more than two categories.
Yes, where it can be any number of categories.
Thank
You will just see, I think in thyroid cancer, we have shared one paper where there were many levels. So these we do a pairwise comparison also where we use this Cohen kappa. So it can be done for any number of categories, not necessarily. Classically, for demonstration and wherever you see like people who are calculating it by hand, like many times this question comes in our here also PG entrance and NEET also. So for them, for understanding, we always demonstrate it with the help of 2 by 2 because it is easy to show the observed and expected probability of this agreement. So that's why it is classically, if you see, they show it like positive, negative. Otherwise, it can be performed for any number of categories, but that should be nominal. Because in ordinal, we'll see that it should be a weighted one, not the unweighted one.
Okay. Thank you. Thank you, ma'am.
Okay, my pleasure. Anybody else, any other question before we move ahead? Okay, so Aditya is asking me to explain the expected. So Aditya, like expected is calculated using a law of probability. And that is, if you can recall your, many times we have read that there are two rules of probability. There is a multiplication rule and there is a addition rule. So we say that probability of event happening event A and probability of happening event B together, if there is a word and between these two, we multiply it. It is known as the multiplicative rule of probability. So here we are using that rule, not we are using like classically Cohen kappa has been designed using this probability rule, and there the chance factor we calculate using the probability. So what is that? We first calculate the probability of chance agreement for positive cases, which is this. Just a second. These two, like if you see this 60 case, this is the number of cases, positive cases by the Dr. A. Then, which is the probability of like proportion of TB cases diagnosed by Dr. A. And this is the proportion of TB cases diagnosed by Dr. B. But these both are positive. So if I have to calculate the probability of both A and B, Dr. A and Dr. B. Since word and is there, That's why I will use this multiplicative rule, and this is like 0.6 multiplied by 0.5. This is your chance agreement for positive cases. Then similarly, we calculate the chance agreement for negative cases. So chance agreement, if you see the negative cases, Dr. A has said 40 cases as negative and Dr. B has said 45 cases as negative. So both Dr. A and Dr. B saying the cases by chance means expected will be again their multiplication. So together, the total probability, like total by chance agreement, will be this value 0.33 plus 0.18. This is how we calculate the probability of both these, like by chance agreement. Am I making myself clear, Dr. Aditya? Okay, thank you. So, but again, I said we are just showing it for you people to understand what is the chance agreement and how this kappa calculates the agreement beyond chance agreement. But you will get these values in the software and you need to interpret it and you need to like give the 95% confidence interval also. So if you see this, so out of all agreement, this P0 tells you like what the raters actually agreed on and P is your expected. So 1 minus P is like beyond chance, what is the true agreement? That is your 1 minus P. And this kappa tells you like what is the total agreement by, observe the actual agreement which was observed beyond chance. So this formula we have seen. So this kappa is the observed improvement over chance in context of maximum possible improvement. So there are few assumptions of this kappa. So what are those assumptions? The first assumption is like the response variable on which we are categorizing, whether it is X-ray or whether it is a slide or whether it is a histopathological specimen or anything. So that judgment, it is made by the rater or a tool. So it can be a tool also, it can be a rater also. It should be on a categorical scale. And categorical scale, again, I have written here ordinal and nominal because there is a weighted kappa also. So this ordinal I have written for the weighted one. Otherwise, if you are just focusing on unweighted kappa, it should be a nominal and the categories needs to be mutually exclusive. So what do I need? What do I understand by this term mutually exclusive? That means if I have labeled one X-ray as yes, I cannot label that X-ray as no. So it is like independence of event, which we have read in a lot of other assumptions like chi-square test or independent sample t-test, that the events are independent. That means here also, if you have labeled one slide or one X-ray as one category, you cannot label it as another one. That we understand by the mutually exclusive. The second assumption is that rater should be independent to each other. That means, and that's how we have to take care in the methodology, that whatever rating I have, I should not, the other rater should be blinded with that. So the raters are independent and one rater judgment that is not affecting the other rater judgment. And the third assumption is the response data, it should be a paired observation of the same phenomena. Paired observation, which I was telling you when Shivam asked that question, like can it be more than two categories? So yes, but the number of categories should be same for both the raters. That means the 2 by 2, 3 by 3, the contingency table should be either 2 by 2, 3 by 3 or 4 by 4. It cannot be like 3 by 2 table or 4 by 3 table. That is like paired observation. Paired means for each category, I should have two values of the rater 1 and rater 2. So that I mean by the paired observation. So this is very important, all these three assumptions. And just to make this phenomena, to make you people understand, just if you see the first table, if you focus on the first table, here there is a rater A and rater B. So both of these rater are rating on the same yes and no. But this is the first one. This is your first case. The second one, the second X-ray, the rater A is saying like yes and no, but the rater B is saying like yes, no, and maybe. So which of these two cases where this assumption of paired value is defined, is not met. Yes? Now for first sample or for second sample?
Two.
Okay, so yes, you are right for the second one. Because second one, if you see, it is not, and again, if you can just remember by the symmetric symmetric or the symmetric contingency table, the contingency table here is the 3 by 2 because there are 3 columns and 2 cells. So that's why the category of the response, it's different for the rater A and rater B. Rater A is rating on only two, like yes and no, where rater B is rating on yes, no, and maybe. So that we mean by the paired observation. So is it clear to all of you what do I mean by this paired observation or the symmetric table, this contingency table? And the other two, like the rater should be independent and it should be a nominal variable with any number of categories. It can be more than two, but again, those categories should be mutually exclusive. So that's the assumption. And then the second, if you just see the hypothesis, the null, because we calculate the inferential statistics, we calculate the p-value, and then we give you I mean, there is a confidence interval is also there. So the null hypothesis is like agreement between rater is no difference than chance. That means if the value of kappa is 0, then we say that it's just a chance agreement. This is the null hypothesis. And alternate hypothesis says that yes, the value of kappa is not equal to 0. And generally we take this as a more than 1. I mean, we take the positive value of it. So that is our null and alternative hypothesis. Then the Landis and Koch, they have given this categorization, what value of kappa you should label as poor or fair or moderate, good and very good. So any value less than 0.2 is poor, but more than 0.2 it is fair. So 0.2 to 0.4 is fair, 0.4 to 0.6, again you can categorize it with two equal class interval of 0.2. So 0.4 to 0.6 is your moderate, 0.6 to 0.8 is your good, and 0.8 onward it is very good. So this is how the interpretation of the kappa values there. Now again, in the beginning, I mean, few slides on just I think few minutes before, I have discussed that it could be a rater, it could be an instrument, or it could be a scale also. So again, the same question, can rater be only human being? In this case, whenever I say like to rater, so is the rater term is only there for human being, or it can be applied to anything apart from human being also?
It can be
Yes,
applied
it can
for
be.
anything.
Excuse me, ma'am. I had a small question. Good afternoon.
yes, Dr. Shivam.
Can kappa be negative, ma'am?
Yes, that's what kappa, if you see traditionally in all the books, they write the value of kappa can be from -1 to +1.
Okay.
Many times it comes also, but generally for all purpose, if you say, they write that the alternate as it is not equal to 0, but it should be more than, it should be on positive side. Because 0, we take that it is, the agreement is because of chance. And if it is negative, then we say that there is no agreement at all. So that's what, even there is no chance agreement. So that's how the negative value of kappa is interpreted.
So
So
basically,
yes.
0 to negative, no agreement, ma'am. 0 to negative is no agreement.
No, 0 is the chance agreement.
Okay,
If the
0 is
value
chance.
of kappa is 0, that
Yes.
means the whatever agreement you are observing, that is only due to chance. If it is negative, then you say that there is no agreement.
Okay, thank you, ma'am. Thank you.
So yes, you all have answered correctly that it is not necessarily only be a human being. It can be a AI, it can be two machines, it can be two scales, it can be two instrument. So anything, two rater, but the same set of like two rater. It depending on the situation, they are rating on the same number of categories. Again, once there's another question in a study. If I'm comparing. Like taking the one diagnostic decision as a gold standard and the other as a normal one. So for Cohen kappa, is it necessary that one of the raters to be considered at gold standard? Like in the beginning, the uses of Cohen kappa, we discussed that you can compare a less experienced to a very good experienced one. So is it always necessary that the other rater should be a gold standard? So what is your answer? So you are saying B. So no kappa measures agreement, but not the correctness. Yes, and that's the bias also which we have discussed in the beginning. That if the two people are misdiagnosing, and if you are just measuring the agreement, then there's no chance that you can pick it up. You by just showing the kappa value, and that's why we will see that many times where the people are like wants to do both the things together, like calculating the sensitivity and kappa also. So in one of the article, I think we have shared that article to you. The person has done both the things, like both the calculating the sensitivity specificity and as well as your kappa also. So for example, there are two machines and suppose they are testing the blood samples for malaria. So this machine A has said like 40 as a positive, and this machine B also said 40 as a positive and 45 here as a negative one. But they are like so should here we can we calculate kappa here if there is a no gold standard? So yes, you are all right. Like Dr. Manita and Dr. Hussein, Ramashish, all of you have answered correctly that yes, we can calculate it. So ideally, in calculation of kappa, like you people have said, that it's not needed. But when you want to do both the things together, if you are already doing a diagnostic accuracy study where you have got a gold standard, then in that case, you may calculate kappa, but there the matrix are asymmetric. So why we call it as asymmetric? Asymmetric means one is a very much experienced and the other is not experienced, or that is very less as compared to the reference one. So in the kappa, ideally we don't require that. And again, kappa assumes both rater to be symmetric, means it treats both the test or both the rater equally. It doesn't differentiate between the two. So that's the term symmetric and asymmetric we use. So now coming to the breakout room activity. So in this calculation
Ma'am,
of
sorry.
yeah,
Ma'am, sorry
please.
to interrupt, ma'am. I don't
Yeah, please.
understand the previous slide, ma'am. So
Okay.
if we, yes, ma'am, can you please explain?
I have introduced two terms, symmetric and asymmetric. So what do I mean by asymmetric? Asymmetric means one rater or one test you are labeling as a gold standard, another as a less to that gold standard. So this is asymmetric. You have labeled these two tests since beginning. But for kappa, if you apply kappa, it treats this whole whatever formula you have taken, it treats both these two together. I mean, at the same level. Symmetric means equal. It doesn't treat one like rater A as a gold standard and rater B as less of that. That we mean by symmetric and asymmetric. So for kappa, we don't need any gold standard. That's what the question was, and that's how I'm explaining. In case of this less and more experience or gold standard, also you can calculate kappa, but that treats both these category as an equal category. That will not give you like in respect to the other. That doesn't give you taking one as a reference. Did you get it?
Yes, ma'am. When we are using kappa for checking the agreement, the test that is being used in that thing should be already a validated one, or how it should be, ma'am?
No, not needed validated, or that is up to you.
Okay.
I mean, that is up to you as a researcher. But if you are putting that statistics and if you have got that value, it treats both these two tests or both the two rater equally.
Yes, ma'am. I
Unlike your diagnostic accuracy, when you
Okay.
have got one gold standard and you are testing your new test against that gold standard. That's why you
Okay.
calculate your, diagnostic accuracy values like the sensitivity, specificity, and all. But in this case, in case of a kappa, in case of a diagnostic accuracy, you can calculate kappa. Why?
Okay, ma'am.
The way I have more experience with less experience, you can do that. But for kappa, you cannot do the diagnostic accuracy studies. Are you getting my point? Because
Yes.
kappa treats both these tests or rater or machines equal. or symmetric. That doesn't place one test as superior as compared to the other test.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Okay, so Dr. Vinu is writing, if we do not know sensitivity and specificity, then kappa can give no. Kappa is not at all about the validity. If you can, those of you who have attended the scale development workshop or otherwise also, you know that kappa is a measure of reliability. It is not a measure of validity. And that's why I said that even if both the rater are misdiagnosing something, what is validity? The true value or the true status. But through kappa, there can be a possibility that the value of kappa is 0.8, but both of them are not saying the truth. But you can say that there is a reliability. So kappa or this agreement is the measure, one way of reliability. If you can recall the reliability, there are various ways of measuring the reliability. Like there is a internal reliability, or which we use the Cronbach alpha. There's the test retest reliability or the temporal reliability. Like with the time it is changing or it is not changing. Then there is a something known as the inter-rater reliability. So this kappa is a measure of the inter-rater reliability. That means like are they saying the same thing or not? So that's it's not about validity at all. Kappa will never tell you about the validity. So coming to this, before we go to the breakout room, like I will demonstrate it. This. Before we go to the breakout room activity. But anything theoretically which you people need, I mean, any question? Then otherwise I'll go to the data set and I'll explain and then we'll go to the breakout. Pardon? No, it is coming. But... Okay. So I will. So for demonstration of this kappa, we have taken this article. We have shared this article with you people, assessing the polypharmacy in the older population, comparison of a self-reported and a prescription-based method. So what is this, in what the author has done in this, like he has just used the data, he has taken two data set, like one from the prescription, which was there in their health insurance, another he has interviewed or probably called all the people and asked about how many drugs they are using. And he has defined like two types of polypharmacy. There is if you see, this was the table, there is a polypharmacy and there is a excessive polypharmacy. So he has seen this 65-year, in more than 65-year people, the polypharmacy and the excessive polypharmacy. Excessive polypharmacy is the use of 10 or more than 10 drugs, and polypharmacy is use of 5 or more than 5 drugs. And then according to both sources, they have, in this case, you will see that they have calculated the sensitivity, specificity, positive predictive value, and the kappa also. Can you see here? Which we were just discussing, because he has taken this self-reported based data as reference means he is taking this as a gold standard. That's why if you are using a gold standard, you can calculate both. So he has calculated the kappa also, and he has calculated these sensitivity, specificity, that means diagnostic accuracy values also. So we will see here what he has done. He has done it in the different age group, like 65 to 74 years, 75 to 84 and 85 plus, and then overall in men and then in women also. So gender wise, he has done for both polypharmacy and the excessive polypharmacy. And these are the values, if you see, these are the values of the kappa with 95% confidence interval. So if you see in the various category, it is overall, if you see in the men, it is 0.60. But if you see the category wise, it is less in the men who are 75 to 84-year age. So we'll see this. So I'll go to the data set. So this was the polypharmacy. This is the article of polypharmacy which we have shared to you people. I've just shown. And then this is the data. So I am opening this. So for we are showing it in Jamovi and JAS both. Why? Because Jamovi doesn't give you the 95% confidence interval. So I'm showing on both. But I think for most of this JASP interface is better. So I'll first open this. Let me open the Jamovi. So we all assume that you are now well versed with Jamovi. Those of you who is attending this workshop for the first time and doesn't know about Jamovi, it is very simple. You can download it simply by just typing over the Google Jamovi, and then the download its solid version. So if I see, is it downloaded? No. Okay. So now it has opened. I will open this polypharmacy dataset. In the meantime, I will open the questions also. So again, this is the problem statement. In aging population, polypharmacy typically defined as concurrent use of 5 or more medicines. It is increasingly common. I am just not reading this. Yes. And then what is the research question? So this research question is how to this prescription-based classification, they agree with the self-reported data in identifying polypharmacy and excessive polypharmacy. So the objective was to compare the polypharmacy status, none. So they have classified the polypharmacy as none, moderate, or excessive based on self-reported versus the prescription data, and to measure the agreement and to explore how they differ by age and gender. So coding, I'll open the data. So let me explain the data set. If I go to variable, so this is the age group. I have already categorized this age group as 65 to 74, 75 to 84, and 85 plus. Then coming to gender, the men and women. This is your self-reported polypharmacy status. That means more than 5 medicine. So no is 0 and yes is 1. Then again coming to the polypharmacy, this I missed, of prescription-based polypharmacy. And then coming to your, this is your self-reported excessive polypharmacy, and then self-reported, this prescription-based excessive polypharmacy. So this is these are the variables. So for this, if you go, you have to download, in analysis, there is a module, which is the Seoul matrix. If you can see this, Seoul matrix, you type on this plus module, see the Jamovi library, and type here simple agreement. So if you type agreement, it will show two module, Seoul matrix correlation suit for Jamovi and simply agree. So simply agree, we will use for the continuous data. We are not using it now. Seoul matrix is for the categorical data like agreement, which we are covering it today. So I'll just, since it is downloaded in my this Jamovi version, so that's why I don't need to do it. For all of you, please download this Seoul matrix whenever you go for the breakout room. Now, again, I'll click this. If you click this, there are various options. like there are many options of correlation. Then there is an option of rater. So if you see this rater, there is a rater reliability and there is a generalizability theory. So for all practical purpose, for today's session, we'll use this option of rater reliability. So I'll go and I'll click on this rater reliability. In this, the interface is simple. It has got only one window. You transfer both these two variable because we have to see the agreement between the prescription based and the self-reported. So this SR and PR, that means self-reported polypharmacy and prescription based polypharmacy. Data format, generally in all these agreement analysis, we use the rater as a column. If you see the data here, there are the two tools are here: polypharmacy, the self-reported and the prescription-based. So we have kept it in the column. So that's why this will always be like raters are in column. This option you can see here. This will be always like raters are in column. There are, if you see the drop down, raters are in rows. That is also there, but we don't use that in case of all agreement. And then if you click on this rater reliability, so rater reliability, you have to click the exact. So this Jamovi gives you like Kohan kappa is the exact kappa. So you have to click on this exact kappa. And if you see this value, it comes. So exact kappa, the value is 0.89. That means the value of Kohan kappa is 0.89. But again, there's a problem in Jamovi. It doesn't give you the 95% confidence interval. So what I will do, and if you just want to see the percentage agreement, that means the observed agreement, which we have learned, like agreement for positive and negative, that is the observed agreement. So simply percentage agreement is the 94.5%. In case of this you can check with the 2 by 2 table also, but I'm not doing that. Here also it will show you that how many of them agreed for positive and negative cases. So overall agreement was 94.5. This is your observed agreement. And this kappa is the agreement beyond by chance. So this is your 0.89. But again, I said that it doesn't give you 95% confidence interval. So that's why JASP has got a better options. So Tanya has raised her hand. Yes, Tanya?
Ma'am, I would like to ask a question that for interrated agreement, how would I, which equation should I use for calculation of sample size? Is it for the proportions?
Okay. For is it your primary objective? See, the sample size is always calculated with for primary objective.
Yes, my primary objective is to compare between two criteria for diagnosis of GDM.
Okay. So so are you using that one criteria as a gold standard or both equally?
Both equally.
Okay. If you compare both equally, then you have to use the agreement. Probably you can use what is it? Okay. So either you can for this separately for agreement analysis, I have not this G power. Probably I don't remember that option. So probably that we can use. But again, let me explore that since how we can use that. So probably when you people will go to this breakout room, then we will see how to calculate the sample size, because specifically for agreement, if you see, I have not done it in any of my paper. So let me check that once, Tanya.
Okay, thank you, ma'am. Thank you, ma'am.
Back from the breakout room, then probably I'll be able to demonstrate it here. Is that okay?
Yes, ma'am. Yes, ma'am. Thank you.
Okay. So then we'll go to the this interface of JASP. So I will open the JASP file. It is already there in your folder. We have shared the JASP dataset also. Like for JASP, you need to save your this Jamovi file or Excel files as a CSV, comma separated, because JASP only import the CSV file. So either you can export your file, Jamovi file as CSV. Or in the Excel sheet, you can again save it as a comma separated. So this is my JASP interface. I will move this back. Let me increase the font size. So this is, if you see the analysis, it's the option of reliability. So this rater agreement, this is the reliability. We have used this option in the scale development also, where the unidimensional reliability was the Cronbach alpha. So using this rater agreement, and how you will make this active, there's a plus sign like Jamovi in JASP also there's a plus sign. If you click on this plus sign, these are the modules. So whatever module you need, you just need to like put it like you can go down and you can see since I have checked this reliability as tick. So that's why it is coming, even the SEM. Right. So this is how you can like make this module because in JAS we don't have to like download that module. You don't only have to click it. So I have just clicked it that's why this reliability option is coming here. And now I will move this SR, that means self this rated this polypharmacy and the prescription rated polypharmacy. And then here there is an option here. If you see what are the options here. So there is an option of Cohen kappa, which is unweighted, Cohen kappa, which is weighted. Then there's a Fleece kappa, and there's something known as the Kreppendorf alpha. We'll discuss this Kreppendorf alpha shortly. For now, I will just uncheck this. I will only show you the Cohen kappa unweighted with 95% confidence interval. So if I see the value is 0.89 with a confidence interval of 0.85 to 0.92. Again, if you see that paper, they have compared it across like gender and various age group. So I'll just show with the age gender. So coming to your edit data, if you click this data will appear. Let's say I will just double click on this gender. So this interface will open. And here you can see in the categorical data already the filter option is there. So you can just click, if I click this, that means the value it is giving it is only for men. So you can go to analysis and see the value. It takes a little bit time. You can see it is buffering.
Excuse me, I had a small question, ma'am. When we are analyzing kappa, does the data need to be coded as 0, 1, or we can put any any values for the categories? 1, 2, 3.
No, any value you can put.
Okay, thank you, ma'am.
So this is for the male, 0.885. Now if I go back and click the women, then again if you come to analysis, then it is 0.896. So it has changed from 885 to 896. So this is for the female. Similarly, but here it will not give you one table where male and female both kappa is there. You have to click it and note the values separately, or maybe just copy paste the result and do it at the end. Similarly, if you go to the age group, let me again put that filter on. And if you go to the age group, again the three filters are here. So for all categorical variable, you will see that it has already created the filter based on the number of categories which you have put. So you can like click one and then note down the other two values. So if I need the kappa of only 65 to 74, then I will put these two as a filter off and then go to the analysis and see. So now the value of kappa is like 0.893. Again, I'll go to the edit data and I'll make both these two as a filter as off filter. So this is how, if you see, the table here. This table. So they have reported, if you see, they have reported the kappa separately for all the age group and for overall also. This men. Similarly, they have done it for women also. And they have taken both these two together, men and 65. So in that case, you have to put two filter on, because they have taken men and they have taken the 65 to 74 years also. So for that, what you will do in the JASP, you have to put two filter on. So in here, you will make like this, and again, you will go to the gender. And here also, like, you have to click this. So now you will have the value only for 65 to 74 men, which they have done. We are just using that as a demonstration, just to show some of the functions of this JASP. Similarly, in JMovie also you can put the filter. You know how to put the filter. You can also switch off and switch on the filter in JMovie. So this is how this is unweighted kappa with 95% confidence interval. So for in JMovie, you will not get the confidence interval. In JASP, you get the confidence interval. So that's why it's better to use JASP for this agreement analysis, because JMovie for fleece kappa it gives, but for Cohen it doesn't. Is it okay before we go to the breakout room? Is it okay to all of you? Or any questions? So I think you can practice on JASP, because if you practice on both, then that much time will be not sufficient. 15 minutes time, and we will like close the breakout room, because there are 3 breakout rooms. So we cannot extend that time, and it's only a 1-day session. Like, there's no tomorrow. I mean, tomorrow we are not having this session, right? So that's why try to finish it in 15 minutes. 5. So there are 46 participants. We are having 9 breakout room. 8. Yes, we have shared the data, Dr. Ravi. We have shared, like, you can see the Google Drive link, or if you wish, do you want to like get it shared on any other platform, then do let us know. But we have shared it over the Google Drive. Experience of the breakout room, like any questions which left unanswered or which needs more clarification from your end. One was like, before going to the breakout room, I was discussing like how to show the result. So result is very simple. If you go through any of the article which we have shared, they just report the kappa, that agreement was moderate, fair, or very good. That's it. And maybe category wise, like which we were discussing, like men versus the age group and any other category. That again, we will emphasize more on the category wise kappa, which I have not discussed now. So because many times what happens, that overall kappa is good, but when you do category wise, in one of the category you might find that it is less or more. So that you can report, and you can report the similar thing. So kappa reporting it's very simple in one line. That's why you will see in many of the article, even if the primary objective was agreement, they've just mentioned the overall agreement and the 95% CI, and said that it was moderate or fair or very good or very poor. So Dr. Morgan is writing in table 2, percentage of self-reported and percentage of prescription. Can you explain? Oh, let me see. I have closed that article, but I'll again open this. So polypharmacy. That's the descriptive actually. Let me.
Descriptive.
So table 2. This is table 1. This is table 2. So table 2, percentage of agreement. Self-reported, prescription-based, sensitivity, specificity. If I come down,
Description numbers.
where is the percentage of agreement?
No, there is 22%.
वो डिस्क्रिप्टिव है 22.2%.
Just a sec. Okay, the overall agreement. This one. Self-reported based. Polypharmacy. This must be this one, the overall, which we discussed. Let me open. I have closed the data set. This must be this one, the percentage agreement, which I've just told you, overall percentage agreement of positive, observed agreement. Of self-reported with the, this thing, the prescription based. This one. But separately for both self and prescription. Okay, let me see. Self-reported. Okay, so you are saying, okay, this is not the agreement actually. This is, okay, what is this? Self-reported base. Let me see what they have written like D and E.
I think this must be the observed agreement, ma'am.
No, but observed agreement, it is between.
परसेंटेज है वो 22%.
No, but this is self-reported. Observed agreement will be both together. But they have given two values. Let me see. They have written something down. Because I focused entirely on the kappa. I couldn't see this. So D is not reimbursed prescription medicine and OTC included, and not reimbursed prescription medicine and OTC not included. D and E.
1% होगा ना 2%.
That might be descriptive also.
Yeah, this is descriptive only. So probably if you go, we need to go to the article to read that. Okay, this is the self-reported description, like maybe 22% how to interpret. If you have to go and read the article, then probably it will make more sense, because I didn't focus on these two. Basically, I focused on kappa, right? But this must be descriptive.
Descriptive.
Then coming to the question of what Dr. Tanya said regarding the sample size calculation. So this was the sample size calculation. I have put the this link in the chat box. So this Narifin, or WNARIFIN, Narifin, this one. If you type that, this gives you the calculation of kappa, because it is not there in statilator. I checked it in the G power also. It is not there in the G power. So separately, it is a separate calculator for this. If you go, like, I'll show you from behind. I typed on the Google. That is this. Again, I'll go back. And I have typed like sample size calculation for agreement studies and this person. So then this has come like Nerf in GitHub. I have just clicked this. And this is a web-based calculator. It has got many other options also, like mean, proportion, diagnostic studies, the Pearson's correlation. And in reliability, if you see this option, this reliability, it has got option of this kappa coefficient. So if you click this kappa, then you can see here there are two options. One is for the two data, that is hypothesis testing. So we are basically dealing with the hypothesis testing, but if you wish to do it only for estimation, then you can use this. So suppose if, let's say, if minimum acceptable for me is 0.4, because 2 to 0.4 is, let's say, it's fair. So I have written it like 0.4, and expected kappa, let's say it is 0.6. So I have typed 0.6 here, and here you have to give like prevalence also. So prevalence, I have calculated, if you want to calculate it on 50%, if you increase the prevalence, the sample size increases. So let's say I'm calculating it on 50% significance level, and this is 5% and 80% is the power. Dropout, I'm just like, let's say I'm keeping it at 0. And then if you press calculate, it gives you like 165, right? If you increase the prevalence, it will increase. So this is how you can calculate. Tanya, is it okay?
Yes, ma'am.
Okay, so you can put like the two values of your agreement of GDM. And many times what we do, like accordingly, the convenient sample size we fix and then we input we change. So depends on the feasibility and your research question, you can choose a sample size. Coming to the weighted Cohen kappa. So this weighted Cohen kappa is an extension of the Cohen kappa. When there is a problem in Cohen kappa, the data is nominal, where it is either in yes, no, or even if you change the category, it is not affecting the nature of the change of those numbers. But now if there's one patient and there are two nurses, and you are like the nurses is assessing them on the pain severity on a 5-point ordinal scale for 10 patients. And those 5 point is like 1 is very less, 2 is less, 3 moderate, 4 severe, and 5 very severe. So in this case, if you see on the first case, both nurse A and B is agreeing on the pain score. In case number 2, if you see, again, they are not disagreeing, but the difference is only 1. Here again, they are disagreeing. 1 and 2, they are agreeing. But if you see this last case, 10th, the disagreement is very high. That means nurse A is saying like very less, and nurse B is saying it is very severe. So if you apply Cohen kappa, it will treat unweighted one. It will treat both these 10 number of patients and this 2 and 3 number patients equally. That means if you see the distance between 3 and 4, so 3 is saying moderate and 4 is saying severe. So distance is less here. But if you see the 10th patient, the distance is very high. That means one is saying very less, the other is saying very severe. So what this weighted kappa does, this assigns a weight to this distance, because if you apply Cohen kappa in such case, it will treat both these 2, 3 and 10 equally. But if you see that there is a difference, means at least in this case, 1 and 2, the one nurse is saying very less and 2 is saying less, but pain is less for both of them. But in the 10th patient, one nurse is saying very severe and the other is saying very less. So distance is more. So that's why, to take into account of these feature, like the distance between the responses, we use the weighted kappa. Because if you see the ordinary kappa or the ordinary Cohen kappa, this treats both these 2 or 3 disagreement equally. So that's not fair for the ordinal data. So Dr. Ravi is saying subjectivity can be limitation in weighted kappa. Generally, weighted kappa is for the ordinal. So subjectivity means like what? I didn't get your subjectivity.
Ma'am, basically in assigning weights, like
Yeah,
if you're going to assign different weights,
yeah.
then would that be a limitation in the weighted kappa, ma'am?
No, actually, there are statistical ways of assigning weights. So there are two types of I think wait for a few minutes. I'm coming to there's a linear way of assigning weight and there's a quadratic way of assigning weight. So depending on your objective, you can choose a method of assigning weight, and then it will not be a biased and it will not be a subjective one, because we are not assigning weight on our own. There are softwares, and based on that calculation, it assigns weight in the weighted kappa. So subjectivity is not there, but again, what is your like objective? Means a research question. If you are doing something which is only related to survey and on Likert scale, you can apply linear weights. And if you are doing something on diagnosis and critical judgment, like cancer diagnosis, where you have to diagnose stage 4 versus stage 1, where the treatment modality will change a lot. So on that context, if you are using something, then weighted kappa, then in that context, you use the quadratic weight. Okay. And for
So,
subjectivity,
ma'am,
you do a lot of
expert
training.
Yeah. So, ma'am, expert evidence and the existing, I mean, the experts coming together and the existing empirical evidence on the subject matter will have a great importance in assigning weights. Am I right?
Assignment of weight is not dependent on the subject. It's a statistical way actually. Because weight we are not like we are not doing. We are only asking their response on a ordinal scale from the two experts. Okay. The weight assignment is done by the mathematical formula. So I think you are confusing or I don't know, maybe I am not able to understand you clearly. What do you understand by this assignment of weights? Are you like telling that are we measuring these distances and assigning the weight on our own or something like that? Because if
No,
you
ma'am. I was trying to understand that based on the clinical decision, I mean, based on the available evidence on, say, particular example, you have just highlighted the case of cancer only. So
okay,
histologically, if you're going to say potentially, malignant
Hello.
adenocarcinoma versus a benign uh, disease which has been picked up,
yeah.
so would it be determined on the existing data which is available in the literature? I'm not talking about the software part of it, ma'am. I'm talking about the understanding of the nature of the condition what is present.
I'm sorry to interrupt, ma'am. Can I say something, ma'am?
Yeah.
Maybe is it like that we need a gold standard for that to weigh something?
Yes.
So for that's what I said that in agreement it doesn't treat one this thing as a gold standard. For gold standard, then you have to do a diagnostic accuracy study. So in this case, if subjectivity, if that is your question, like in methodology, then for like saying then one like expert consensus which you were just telling, you can take it as a gold standard and then calculate the kappa, which we have discussed initially also that that is also one way of doing it, which this person has also done it like with the polypharmacy. He has taken the self-rated as a gold standard and then calculated the prescription, the agreement of prescription based polypharmacy, right? So this that way the subjectivity which you are saying, that is again it can be you can remove the subjectivity or you can lessen the subjectivity again with training, because if you're saying adenocarcinoma versus some other carcinoma, so you should have a clear cut definition. That is again one bias. If and that's why you see that there we have shared many articles, they have used some classification, let's say femur fracture, they use Gardens classification, or for TNM classification of a cancer, there is a set pattern like this, then this will be classified as TNM classification 1, 2, or 3. So using a particular way of classification of classifying disease and training the rater using those classification, that will help you to remove this subjectivity. And again, if you're thinking that professor is a trained one, because if he has done a lot of histopathology or grading or maybe by the clinical examination, then you can see the newer trained resident, if he has trained them well. And then if we measure the weighted kappa, if it is an ordinal scale, then you can see the agreement and you can remove this subjectivity.
I'm like in the ma'am in the this femoral one, the
Yeah.
done by X-rays, they took one
Yeah.
as gold standard.
Yes. If we have like a, I think let's say if we could discuss that article, but that article they have taken three sort of resident. There was a surgical resident, there was a trauma surgeon, and there was a orthopedic resident, and then there was an expert also.
Yes,
So they
ma'am.
have used all sort of they have taken six rater, two from each category, and then there was a one expert also. So there are ways of doing that. That's basically the methodology part. How do you want to, with what stringent criteria and to what accuracy you want to do that, Dr. Ravi? Is that okay? I don't know
Ye-
whether
Yes, ma'am. Yes, ma'am. Ma'am, we can continue, ma'am.
you are not satisfied, but still, it's okay.
It's okay.
So this is like this is let's say this ordinary kappa. If you see this. This will be less accurate for the ordinal data, because disagreeing, if we equate both two together, disagreeing distance between the two response by 1 point and then distance between the two response by 4 points. So this is not fair for ordinal data. That's why weighted kappa is needed. And this weighted kappa, it gives assigns a weight to the distance. So let's say if there is a zero distance, difference is zero. So let's say it assigns a weight of 1. And if the distance is, let's say 1, then it may assign it as 0.8. Similarly, the distance is 3. It will assign a less weight, but it will, and if the distance is 4, it assigns again less weight. So you can see this is just for example that it assigns a weight. It doesn't treat everything as black and white. Like if you go by the traditional kappa, it treats all disagreement, all agreement as 1 and disagreement as 0. Yes and no. It doesn't take care of those partial disagreement when there's a distance is less. Like if I say a very accurate and accurate, the distance is less. So that's why weighted kappa gives accounts for this or adjusts for this close category, and that's why it should be used when the category is in ordinal in nature. So I think I was discussing this when Dr. Ravi asked this question, but again his question was a little different one. So coming to this again, statistical part, there are ways to assigning weight, and that's there in the statistical part. If you assign, if the nature of your agreement analysis is only like a survey on some scale instrument on 5-point Likert scale, then you can use this linear weights. But if it is something related to diagnosis, clinical judgment, where this, change in distance matters very much in treating the patients or choosing a particular type of therapy, then generally we should assign a quadratic weight. Quadratic weight means the less distance, it calculates with more severity. So it's disagreement, it adjusts the disagreement using the square, because if you can remember the quadratic equation, it is like ax square plus bx plus y, whereas a linear equation is y is equal to a plus bx. So there's no square or cube form in case of a linear equation. I'm just telling you very grossly. So linear weights means just it proportion to distance is assigns weight, and in quadratic, since it uses the square, so this adjusts disagreement as a square distance, which is a severe adjustment because you are doing something which is important for the patient well-being and in the clinical judgment. So ultimately in weighted kappa, we adjust for the distance, and it reflects the realistic agreement in the ordinal data. So this was one paper which we have shared with you, like measurement accuracy and reliability of a self-reported versus measured weight and height among adults in Malaysia. And they have used again this kappa in their analysis. And if you see the abstract, they have used the weighted kappa statistics analysis to show that there was a substantial agreement between the BMI classifications derived from the self-reported and the actual measurement. It was as high as 0.92. And this is again this is the table which they have given. Again, underweight classically, it's just the descriptive they have written here. And overall here, they have written the Flees-Cohen-Kappa statistics. So again, there's one term, like if you see, there's a Flees, they have reported this. So in this article, they have reported this Flees-Cohen-Kappa. So there is this term also, which is the Flees-Cohen-Kappa, because if you see this Flees term, generally we say that it is more than 2 rater or more than 2 instrument. But this weighted, when you apply a quadratic weight, then they use this term also. So Flees-Cohen-Kappa is a specific implementation. Whenever we assign weight, the type of weight is the type of quadratic weight. And for linear weight, you can use the simple weighted kappa. But for quadratic weight, there is a specific term. We've just mentioned this because you may find this in the article, Flees-Cohen weighted kappa. Okay, so that's just the difference. So now there are various terminology which is there in the Jamovi. I'll show you all those terminology in Jamovi. So there is something known as the exact kappa. That the same which we have just put the exact kappa. So this exact kappa is same as the Cohen's kappa. So it gives you only single summary or the single number, and it measures the overall agreement across all the categories. and it treats all the categories equal. That's what we were discussing. It treats the category as a nominal category. Then there is something known as the category wise kappa. So what is a category wise kappa? In each category, it calculates the agreement. Because if you click that, there is a separate kappa value for each category and one kappa value for each of the category. And if you want to identify the strength and weakness of our agreement in category wise, then this is great for identifying the strength and weakness of each category or the classification. So why this category wise kappa is useful? This is useful because if there is overall one kappa, that masks the disagreement or a poor agreement in specific classification. So that's why this is important, because we will show this. We have shared this article with you where using the RC path system, the thyroid FNAC was read by the I think 3 pathologists in the 100 FNAC slide. So if you see these were the categories. Thyroid 1 was non-diagnostic, 2 was benign, and then going to the 5 was malignant. So overall kappa in that study was 0.7, which was very good. But if you see the category wise kappa, the category wise kappa was very poor for this thyroid 3A, which is the middle one, and the thyroid 3F, which is this category. So category wise kappa is helpful because if there are intermediate categories and if there is a low agreement, you can say that it is good for the benign and malignant, but it is not good for the intermediate categories. So this is the difference between the exact and category wise. So exact kappa tells you the overall agreement, whereas the category wise kappa tells you the agreement within each category. And that's how. Now coming to, there is another term which is known as the pair-wise kappa. So pair-wise kappa is again like, it is something like post hoc. If there are 3 raters, it gives you the pair-wise kappa between one is the overall. So pair-wise kappa generally done if there are more than 3 raters. So let's say there are 3 raters, you can calculate fleece kappa also, which we'll discuss, or otherwise you can calculate. I mean, that option is there in Jamovi. You can calculate the pair-wise kappa for each possible pair of raters. Let's say there are 3 rater A, B, and C. It calculates the kappa between A and B, A and C, and B and C. And we have used this in that femoral neck example. So let's say if there are more than 2 raters, then if there are rating, so we can see how consistent each pair of rater is. For that, generally they use this pair-wise kappa. So now coming to the second activity, in this fleece kappa, we have used this article, which is the comparison of WHO based and the non-lab, WHO lab based and non-lab based CVD risk chart among the hypertensive adults attending primary healthcare center in West Africa. And if you see there, generally, if you see the risk stratification of WHO, this chart, generally there are 5 categories. So green is less than 5% to yellow 5 to 10, 10 to 20, 20 to 30, and more than 30. But in that paper, they have clubbed these 2 categories together. So they have kept 3 category: low risk, second was moderate risk, and they have clubbed these 2 together, high risk and very high together. So there is a 3 like low risk, moderate risk, and high risk. And this was one of the table which we have taken. So they have shown like a lab-based CVD risk. Again, they have shown this category-wise. That means like agreement between category-wise. And here you can see it is a symmetric table. That means 4 by 4 contingency table. There are 4 columns and there are 3 and 3. One is 4 is there for total, 3 and 3. So there are 3 columns and 3 rows. And if you see the kappa, it's okay. No, they have not given the category wise, they have given the overall kappa here. So this was 0.76, 0.775. And so if I go to the article and the question, so this was the exercise. This was the paper. So they have written that there was a substantial agreement of 0.766. And if you come down, again the same table, this is the same table which I've just shown. They have like done it on females in more than 60, less than 60. If you see this, in the less than 60, you can see the kappa value was very less, 0.2. It was very less, but it was good for more than 60. Again, for male, female, it was almost equal. So in agreement analysis, you make such stratification and report. This is Bland-Altman. That is not for now. If you come to the question, so question is again, in a primary care setting, if I'm working as a resource, that's what the author said, that in a resource limited setting, you can't do this lab-based risk stratification. So they've just seen the comparison of non-lab based with the lab-based version, and they've calculated the kappa. So I have to just, objective is to calculate and interpret the percentage agreement and interpret the Cohen kappa. But if you see, they have not used the weighted one. They have just simply used the simple kappa. Whereas since this risk stratification is a ordinal scale, because low risk, intermediate risk, and high risk, that's ordinal. So ideally, they should have used the weighted kappa. So I'll go to the data set. I'll open this Jamovi. But again, in Jamovi, you don't get, there's no option of weighted Cohen kappa. Let me see. So this was, I'll explain the data set. This is the data set. If you see, this is your gender, and then it is the age, which is continuous in nature, smoking, no and yes, and diabetes, no and yes. And this is your lab-based CVD, non-lab-based CVD scores and lab-based CVD scores. And using, we have categorized this using a score. So this is the non-lab-based CVD score. And you can see, if you see the formula, we have like recoded this. Less than 10 is low risk, less than 20 is moderate, and more than 20 is high risk. And similarly, you can use the same classification for the lab-based and non-lab-based again. So these are the two classifications. So if I have to go to analysis, I will click this Seoul matrix. I will go with the data reliability. But again, here it will be only simple kappa. If I move these two, lab-based and non-lab-based here, since there are two raters, I can only use the exact kappa. And here too also, you know that it doesn't give you the 95% confidence interval. So the overall kappa was 0.77. Now coming to the JASP, if you see the JASP, I'm just opening the JASP. So this was the data. I'll go to this reliability, click the rater agreement, and I'll move this, both these two, non-lab based and lab based. Okay. Okay, I have to make this as a, because it is nominal. Yeah, so you can change this to ordinal. Here also you can change this to ordinal. And then again go to analysis. Here I will uncheck this fleece and Krippendorf. And instead of unweighted, I will click this weighted. Again, it asks for the options, whether you want to put the quadratic weight or the linear weight. So let's say if it is important for me to classify high risk versus intermediate risk, because that will help in treating the cases, I might use the quadratic weight. And then I will move these category here in the variable section. And this will give you the weighted kappa, weighted Cohen kappa with a 95% of confidence interval. So the weighted Cohen kappa is 0.674. So if you see the same value in the JAMOV, it was coming 0.7. So unweighted always gives you high agreement, but weighted gives you the less. And we have seen the features of that. And if you see the 95% confidence interval, it is 0.552, 0.8 or 0.79. So this is regarding your weighted Cohen kappa. And if you apply the linear weights, let's say if it is 0.674, if you click on linear weight, then again it will be more, like agreement will be more. So depending, that's what we discussed, like what is important for you, depending on that, you may apply a quadratic weight. If it is a simple survey where you are using Likert scale to diagnose something, to screen something, then you can go for the linear weight. But if it is affecting your clinical judgment and management protocol, in that case you use the quadratic weight. So this is there. We have shared the data set with you people. You can practice these two options.
Excuse me.
Yes, Dr. Shivam.
I had a small question, ma'am. I was reading about a particular study which used weighted kappa. I could not really understand the study. That was on yardstick development, ma'am, in dental research. So why is that needed? And they had used weighted kappa. So how can we use weighted kappa in those yardstick development studies? And what exactly is the purpose of that study, ma'am? I was just
Have we shared that study?
No, actually, that was
Okay.
that was just a study which I was reading. But what
So can
is
you
the
share
purpose
that
of this?
study?
Yeah,
If you
yes,
can
ma'am.
share it, we will just go through that and I'll show it here if they have used it.
Okay, sure.
Okay, so in the group you can share, or in the WhatsApp group also you can share.
Okay, sure, ma'am. Sure, I'll
And
do.
in the meantime, you people are doing that. We will just see and I'll get back to you.
I'll do it.
This was the article which Dr. Shivam shared. A new yardstick for rating dental arch relationship in patients with complete bilateral cleft lip and palate. So if you see, 11 cleft team orthodontist from 5 countries worked on the project for 4 days. And they have like standardized 776 sets of standardized plaster model from 411 patients. So what they have done, if you see the methods, they have used a ordinal scale.
Okay, ma'am.
I'll just show.
Quality of the
Method. Typically, group of clinicians is assembled to rank order of sample of case from good to bad, or to subdivide them into ranging from good to bad. And this initial ranking is based on the rater's subjective judgment. When consensus is reached on the qualities or characteristics of the sample, that is influence the shape of a consensus conview rating system. So this is not yes and no. They have written like rating system from good to bad. So it's in the ordinal scale. And the term yardstick, they have used this yardstick, and why they have used, and they have not used the overall. Like since there were 2 teams, team A and team B. In team A, there were 4 raters, and in team B, there were 4 raters. So they have only given pair-wise comparison, which is there in the JAMOV. I'll just show you. They have not given overall. So they could have used in team A fleece kappa also, showing the overall agreement of 4, like more than one rater. Which we have not covered. I'll tell you, when there are more than 2 raters, you can use fleece kappa. But they have used the pairwise comparison, like rater 1 to 2, 1 to 3, 1 to 4, and then 2, 3, 2, 4, and 3, 4. This option is there in Jamovi, but this option is not there in JASP. So for this agreement, use both JASP and Jamovi interface. For weighted, you take the value of weighted kappa from the JASP, and for category wise, you need to give, you need to use the Jamovi, because if you see the JASP interface, that doesn't give you the pairwise. Pairwise, you need to select them. Separately select using the filter option. Those two only. You move only those two variable into the box and then see the pairwise. Otherwise, in one table, it doesn't give you JASP. Whereas in Jamovi, it give you. We'll just see in this example. So Shivam, is it clear why they have used the weighted Cohen kappa?
Yes, but I think because they have ordinal scale categories, right?
Yeah, they have written that rank order. It was a rank order of sample of case from good to bad, or to subdivide them into group ranging from good to bad. So it's a ordinal. It's not nominal.
No, but in this study, ma'am, are they comparing something to the gold standard, or they are trying to develop a gold standard? Okay.
No, they are not using a gold standard. They are just using all the experts and seeing the agreement.
And ma'am, based on this weighted kappa, what is the judgment that we'll make? Because ultimately our aim is to develop the yardstick. So if the weighted kappa is good, can we take any one of the thing as
yeah, if you see this, overall also all the category or all the group wise also, it is more than you can say more than 0.7, which is a very good agreement.
Okay.
So in the conclusion, you can see what they have concluded.
Yes, ma'am.
Because that's ultimately why the author has done the study and what was their objective.
Yes, ma'am.
For that, you have to see the probably.
I think conclusion, first paragraph.
Conclusion probably they have not written separately. In order to further facilitate the use of these newly developed chassis, we identified reference model for each of the 5 categories. These assist calibration are used to anchor sets during scoring session. So basically, they have used to standardize. That's what they said. If you see the initial objective, they have written 11 cleft limb orthodontists from 5 countries worked on the project for 4 days. A total of 776 sets of standardized plastic model from 4 to operate complete. So conclusion, 3 bilateral cleft lip and palate yardstick for different development stages. So they have used like 6-year, 9-year and 12-year.
Okay.
One for the deciduous dentition, one for the mixed, and the other for the permanent dentition at 12. So they have defined the yardstick. So basically yardstick, using these they have developed that model, and on that model they have shown the agreement of all those like 4 raters, pairwise agreement, and they have shown that it was more than 0.7, which was a good agreement. That means the model was good and you can accept it. That to take help from surgery. Okay.
Okay. Yes, sir.
So I'll just close this and I'll go to the fleece kappa.
Hello. And basically, if the agreement is good, then the yardstick is accepted. Like that, that method is accepted.
Yes, you are right.
Okay, thank you.
Now coming to the fleece kappa. So this fleece kappa is basically whenever till now we have seen the 2 raters or the 2 instrument, like WHO versus lab based versus non-lab based, or we have seen like seeing the self-rated prescription of polypharmacy versus the this thing prescription based polypharmacy. So there were 2 columns of rater. But if you have got more than 2 raters, like in this example, which Dr. Shivam has just shared the paper, where there were 2 teams, and in those 2 teams, there were 4 raters. So if there are two or more raters, which we might call them as judges or observer, who are responsible for measuring a response variable on a categorical scale. Again, here the response variable is a categorical scale, and here they define something as a unique rater and a non-unique rater. So if you go by LERD, they specifically say that in case of a fleece kappa, even if the raters are unique or non-unique, in both cases you can go for the fleece kappa. But if the raters are non-unique, what do I mean by non-unique? I'll just explain what is this non-unique. So suppose if I'm evaluating, first I'm telling you what is this fleece kappa. So suppose I am evaluating a patient, and patient is having infection. So each patient, it is randomly seen by 4 different set of doctors, and their decision will fall into these 3 categories: prescribe antibiotic, do not prescribe antibiotic, and request for a follow. So let's say if I have selected 4 doctors and I have given 10 subjects or 10 patients to them, and they have categorized all the patients into these 3 categories: prescribe antibiotic, do not prescribe antibiotic, and request for a follow-up. So measurement goal is I have to see the level of agreement using these 3 scale, which is, the response scale, and to see the agreement amongst these raters for these categorical decision. So fleece kappa, again, the same concept which we have learned in the Cohen kappa, that will be some measurement of this chance agreement will always be there. So again, this fleece kappa measures the above the chance agreement, what is their agreement which is beyond chance. So again, there are a few assumptions of fleece kappa. One assumption is that the response variable, it is measured on a categorical scale, which can be ordinal or a nominal scale. For ordinal, definitely we'll go for weighted fleece, and the response variable must have the same number of categories. That means again, it should be a symmetrical contingency table, 2 by 2 or 3 by 3. And the raters should be independent of each other. That means the one rater judgment does not affect the another rater judgment. Coming to the unique versus non-unique rater. So suppose if there are a pool of 20, let's say there's a pool of 12 raters and there are 4 X-rays. So what is a non-unique rater? If from that pool, if I select 3 rater and give, I make 4 groups like this. One X-ray I give to one set of people. The other X-ray I have given to the other set of persons. The third X-ray I have given it to the other 3 people. And the fourth X-ray I have given to the other fourth set. So in all these 4 X-rays, there are 3 raters for all these. But these 3 raters are non-unique. Why they are non-unique? Because they are not same for all the X-rays. So this is the non-unique rater. Then what is a unique rater? If from this pool of 12 people, I only select 3 rater and I have given all the X-rays to these 3 rater. That means these 3 raters have rated the X-ray of being any presence or absence of disease, then they are known as the unique rater. So in case of a fleece kappa, even if there are non-unique rater, that means number of raters are fixed for each X-ray or for each slide, but they are not the same for all the slide. That is the non-unique rater. So fleece kappa can be applied to the non-unique rater, and according to assumption, they said that this is more helpful if there are non-unique rater. So the hypothesis is like the agreement between the rater is no different than the chance agreement, which we say as 0. An agreement between the rater is different from the chance agreement, which is the alternate hypothesis. For example, this is one example which was showing we have shared this paper like diagnostic accuracy and reliability of non-contrast CT markers for acute hematoma expansion among radiologists. So there they have used this. If you see, in case of they have taken all these several markers like IRR shape, satellite sign, island sign, and they have used the rater. So how many raters were there? So there were a radiology resident and a neuroradiology fellow, and there was a radiology fellow and a neuroradiology fellow. So they have used Cohen-Kappa for these two raters, and for the three rater, like radiology fellow, radiology resident, and neuroradiology fellow, they have used the Fleece-Kappa. So in the same case, you can see you can use both. If you are using all together combined more than two rater, you may use Fleece-Kappa. If you want pairwise between two, then you use Cohen-Kappa. Now there is something known as the inter-rater reliability, which option is there in the JAMOV. So what is this inter-rater reliability? Basically, if there are more than two raters, and in case of this FLIS also you can apply. But if you click this inter-rater reliability, this gives in the JAMOV, this gives a value of light kappa. And this light kappa is also like for more than two, you can say more than two rater. But for two rater, the value is same as the Cohen kappa. But if there are more than two raters, and if you click on this inter-rater reliability, then JAMOV gives the value of light kappa, and it also gives you the 95% confidence interval. But the calculation of this light kappa versus the Fleece kappa, it's little different. In case of this light kappa, what it does basically, it is the generalization of a Cohen kappa for more than two raters, and it compares the pairwise comparison, and then it takes the average of all those three comparison. So that's how it is different than the Fleece kappa, because the Fleece kappa calculates the agreement the way you have seen with the Cohen kappa beyond chance. But this light kappa does the pairwise comparison and takes average of this. So this also you get in the JAMOV as an output. So the difference is again in case of a light kappa, but for light kappa, it should be a unique rater. That means the same rater should be rating all these slides or all the sample. But in case of a Fleece kappa, you can have a non-unique rater. In case of a light kappa, I mean, all the 2x2 table, it should be all cases should be filled up. There should not be any missing data. But Fleece kappa deals with the missing data also. And this rater, again, it assumes same raters throughout, which we have discussed. And this Fleece kappa, there is a possibility that non-unique raters can also be there. So for this article, we have used this breakout room activity. We have used this inter-observer reproducibility of Royal College system for reporting thyroid cytology, experience from the Egyptian National Cancer Institute. And there they have used this, you can see. They have used a category wise, which I was telling you in case of JAMOV, you get this table. For each category, I'll just explain the question. So they have used these, let's say 3 and 3, 6 categories of RC path classification. Thyroid 1, 2, 3A, 3F, 4 and 5. And then they have seen the agreement. So if you see the category wise agreement, we have seen this with in the slides also, that it was less with the intermediate category, like thyroid 3 and 3F. And it was very good for the malignant one and for the benign one. So this advantage you get if you report a category-wise kappa. Now, in case of a JAMOV, also there is no option of weighted Fleece kappa. And in JASP also there is no option of weighted Fleece kappa. So if there is an ordinal scale in Fleece kappa like this, where you have to move from benign to malignant, then what option is there? Then there is something known as the Krippendorf alpha. Now, Krippendorf alpha takes care of everything. In the beginning also you have seen that these two options were there both in JAMOV and JASP. So this Krippendorf alpha, it is a statistical measurement of agreement which works for any number of raters. It handles the missing data also, and it is useful for any type of data, whether it is a nominal data or a ordinal data. For all you can use the Krippendorf alpha. So even like weighted Fleece kappa option is not there. So instead of that, you can report this Krippendorf alpha. And raters, there's an option you can choose a nominal or ordinal scale. And the value again, it is same, like a little bit different. Like in case of Krippendorf alpha, if you can recall the Cronbach alpha, so value of 0.7 was acceptable. Similarly, here also at least 0.67 is the acceptable. So here you should not have a value less than 0.67. So less than 0.67 is not acceptable. So criteria is little stringent here. It is not 0.4 or 0.5, then you cannot say it is a fair. For this, it should be more than 0.67, then only you will say that the agreement is this thing. It's of good or acceptable agreement. So before I go to the prevalence paradox and the biases, which Dr. Ravi asked in the beginning, what are the various biases in reporting the kappa? I'll show this in the data set. So this, let me open the Jamovi data. Let me first show you the paper. So this was the paper. And they have written like all low SARAD. One was the non-diagnostic, then suspicious, then malignant, all those classification. They have this table I have just shown you. In the various classification, you can show the agreement. And here, ideally, they should have used the weighted fleece kappa, but they have used a simple fleece because I don't know, whatever was the reason for them. So this was the article. Now coming to the data, coming to the question and the data set. So data and exercise. This is the thyroid cancer. I will open the data in the Jamovi. I'll open the question. So question is again, FNAC is a widely accepted tool for preoperative evaluation of thyroid nodule. And this Royal College of Pathologists classification system is used to standardize reporting and guide treatment. So they just want to see the inter-observer variability. So inter-observer agreement using fleece kappa. And then we need to identify category which exhibit least agreement. So let's go to this data set. And there are 3 observers. And if you see the data, it is like okay, this will move up. So these are the levels like 1, 2, 3, 4, and 5, and 6 for various classification of thyroid nodule. And then there were 3 raters. So I will just open the same, going to Seoul matrix, using the rater reliability, move these 3 values here, these 3 columns in this variable section. Coming to the rater reliability, click the fleece kappa and confidence interval. And here if you see, it gives you the category wise kappa. If you see the category wise kappa, this gives you the category wise kappa. Okay. Unique and non-unique rater. Aditya is asking me to explain. Unique rater means, like, let's say, Aditya, if me and from the amongst the faculties of AIMS Patna, there are 9 faculties. Okay. So me and Dr. Shamshad, if there are, let's say, if there are 10, although we don't see slides, but let's say we have seen the slides of 10 patients of tuberculosis, and we need to say that it is positive for this tubercle bacilli or negative for tubercle bacilli. So me and Dr. Shamshad has examined all the 10 slides and said yes or no. I'm telling you for 2 raters. Let's say there are 3. So let's say another Dr. Mahinder. So we all 3 have rated the 10 tubercular slide, this AFB slide, for yes and no. So this is your unique rater, because rater are unique for same for all the slides. So this is the unique rater. Now there are 9 faculty, and from this pool, let's say slide 1 is rated by me, Dr. Shamshad and Dr. Mahinder. Slide 2 is rated by Dr. Sanjay Pandey, Dr. Alok Ranjan, and Dr. Let's say Shivaji. 3 different people. Again, slide 3 is read by me, Dr. Shamshad, or me, Dr. Sanjay Pandey, and Dr. This Vijay. So are you getting? So there are random pairs. Not pairs, means random set of 3 people. which I am identifying from a pool of 9 people, and they are rating each slide. So the number of raters is fixed for each slide, which is 3, but it is not the same rater which is rating all the 3 slides. So that's the all the slides. So that's the difference between the unique rater. Unique means fixed number of rater for all, which is there in case of a Cohen kappa. In Cohen kappa, you cannot go for non-unique rater. Cohen kappa, all the two, that's the assumption. All the two same person rated all the slides. So will the same person, how we can estimate? Yes, you have to. That's how the fleece kappa is. Because we assume that the training will be same. If there is a pool of, you identify these observers from, let's say if there are 10 senior residents, so you will have 3 raters for all, let's say X-ray, but the rater will be different. So in that case, you will label one person as rater 1 and you will enter that finding in observer 1, this one. I'm showing you with the data. So this is first rater, this is second, this is third. So the first will be any person can be there in the first, the second will be different from the first, and the third will be again different from the first and second. Okay, but they will not be the same for number 1. That means this FNAC, number 1 FNAC, serial number, this will be dealt by 3 different set of rater. This will be by 3 different, or it may be same also. Maybe same means one person might be same, 2 different. So in different permutations and combinations, it might be there. Why actually in methodology many times why we do it? Okay, but Vinu is asking all the slides X-ray or patients are different. Yes, that's okay. But see, it is again done to see what is the overall agreement if there are many raters. And like I'm doing some education program, agreement is again the same. The first observer, the value will be written in the first column, the second value will be written in the second column, and the third value will be written in the third column. That's how we measure the agreement. So it is not the person specific. It is the rater, and the rater in this case can be non-unique. It may be unique also, like Cohen. Because we assume that everyone is trained to read a X-ray or to a cytopathology. Rather, to judge a clinical program, if I am training my new set of residents for some histopathological examination, and if there are 10 PGs, so it's better. Why I should see agreement with only 2, where I will give it randomly to any 3 people, and then I'll see the agreement. So that the measurement will be same the way you are seeing it with the fleece kappa. Yes, slides will be different. Means like again I said that the raters combo will be different. There can be like one combo where 1, 2, 3, the other will be 4, 5, 6, and like that. An agreement will be measured. Again, it is only you are labeling first observer, and this first observer will be different for all slides. Now coming to, is that okay, Dr. Vinu? No, ma'am. Okay. Then you say, okay, trying to understand.
I think, ma'am, her query was this, that the same set of slides should have gone to all the 3 people in terms of for an agreement to arrive. I think that is her query. Same set of slides.
Same set of slides.
Yeah, for example, if there are slides 1, 2, 3, let's say, for example, there is one slide, it goes to observer 1, observer 2, and observer 3. Yeah, that is what has happened over here also.
Yeah.
So
But
I don't know
I think
what's the query.
he's saying that whole idea of checking agreement is lost. No, dear, why it is lost? In fact, see, if there are many slides, I am doing it regularly in my histopathology section or my radiology is this thing. If one person is rating those many X-ray, it will be very difficult. Because there will be, like Dr. Ravi was asking, also biasness. Towards the end, if I have to judge so many X-rays, maybe towards the end, I will just say yes, no, and I'll just rush off. Because there is a burden of rating also. If I have to rate all the 100 or 200 X-ray. So this is again a good, this thing that if those you assume that the raters have gotten the same training, they are at the same level. So why the purpose will be lost? Because if everyone is at the same level, here the rater will not be an experienced one and a very less experienced. Maybe generally from a random pool we select, where the baseline we assume that all will be either the PGs or the senior resident or all the faculty or something like that. So it will not be lost at all. Rather, it is one step ahead, even if it is non-unique. And if there is agreement, that means your training is very good, and you can leave your diagnostic parameter everything to the resident. Because I mean, of course, with if you can have a good experience one also, and if you can see the agreement between the good one and also, but if everyone is saying from a random pool, and if you are having a, like, let's say agreement of, let's say 6.6 and 0.7, then that means your training is very good and they are very intelligent to pick up all the classification. That is one step ahead. Okay. And that is more generalizable. Then you will not be like keeping it fixed to 2 raters or 3 raters. If you are selecting from a pool of rater, and in spite of that, that means that classification is so objective that everyone is labeling or categorizing it, because generally it is done for using some classification, like let's see RC path classification, how the people are understanding this classification and labeling the slides. So if classification is so clear cut, and if in the random pool also the agreement is good, that shows that the classification is very objective. Okay, like we say like Glasgow this coma scale. If there is an agreement in any random set of people, for a patient, if 3 people are doing that, then that means it is very objective. So it is one step beyond that 3. It is the purpose of measuring the agreement is not lost at all. Probably I don't know whether I'm making sense to all of you or not, whether it is only Vinu or. So the final fleece kappa is a representative.
So, ma'am, in fixed raters, all the slides are rated by in Cohen's kappa, which is a fixed kind of thing. All the slides are rated by one observer in the first column, and all the slides are rated by second observer in the second column.
Yeah, that is true for Cohen.
And in a, let's say, non-fixed scenario, let's say till slide 7, observer 1 is different, and from 7 to 16 the observer is different.
I mean, it is not so that if there are fixed rater, you cannot use fleece. Are you getting my point? Like Cohen, even if all these 3 observer are same for all the slides, then also you can apply fleece kappa. But if the raters are non-unique also, there is an advantage that you can still go ahead with fleece kappa, whereas in Cohen you cannot do that. The rater should be fixed. If you change the rater in Cohen, there's no way you can measure.
That's what I was wondering, that in FLIS we say that, let's say we have 10 patients, and observer 1 rates all the 10 patients and observer 2 rates all the 10 patients. So we have 2 columns. And in non-fixed, let's say observer 1 rates only 3 patients, and the rest 3 to 7 patients are rated by some other observer.
Yes.
So this is an example of a non-unique rater.
Non-unique, yes. In Cohen, we cannot have non-unique.
So we cannot apply Cohen in that case.
No. In case of a Cohen, that's the one of the very important one is to have a unique rater for all.
Right.
But in case of FLIS, it may be unique, it may be non-unique. Okay.
Yes, sir. Yes.
So, in case of a non-unique rater, let's say, you cannot have a pairwise. Are you getting my point? I don't know whether I'm making sense to you or not. See, I have shown this is my output, and I have shown you here the fleece kappa. So overall value of fleece kappa is, let's say, 0.73. 0.73, okay? And the p-value is less than 0.001, right? Now see this table, the category-wise fleece kappa. If category-wise fleece kappa, if you see the least is in thyroid 2, 0.65. So it is very good for thyroid 3A, but not for thyroid 2, means the second level of classification. It is good, but less as compared to others. This pair-wise comparison, this category-wise comparison, again, and now if I click this pair-wise comparison, so it will give you a comparison of pair, means between 1 and 2, 2 and 3, and let's wait for that. Number of patients are more. What?
No. It's छोटा है, gentle light speed. I don't know what's happening.
Should I close it again, open?
हाँ.
Let me do that because it is taking time. Don't save. I'll again open. So Vinu is asking, so the final fleece kappa is a representative of all individual kappa. Yes, it is the overall you can say agreement. So you can have an overall agreement also, or I'm just showing. So these three observers are here, and this is the fleece kappa. And if I click on the pair-wise kappa,
Exact को click करना हो तो भी बनेगा.
yes, yeah, this one, because this pair-wise gives you the value of exact kappa. So this you can see. This is giving you a pair-wise comparison, means with observer 1 and 2 it is 0.7, and with observer 1 and 3 it is 0.8, and with observer 2 and observer 3 it is 0.668. So normally this pair-wise comparison we only go when there are unique rater, means same set of people have done the data set. If you go to the data, so all these three, observer 1 was same for all the slides, observer 2 was same for all the slides, and observer 3 was same for all the slides. So if you have to show the pair-wise comparison, then the rater should be unique. In case of a non-unique rater, you can only report this fleece kappa with the 95% confidence interval, which you can see here. This, if you click this 95% confidence interval, it gives you the value of 95% confidence interval. And it gives you a category-wise kappa also. Whereas, if you go to the JASP, it doesn't have these option of category-wise and the pair-wise. You have to do it manually. Manually means like using the filter. Till the time it is doing, I will come to JASP. And here, if you move these one observer 2 and observer 3, this is the fleece kappa. Again, weighted fleece kappa option, it is not there.
Ma'am, this can be tried, on the question answers being given by the various MBBS students being examined or MD students being examined by the faculty. So then we can see the faculty agreement on the papers what are being
Yes,
answered.
yes. Actually, many times it is done also. That's why you see, like these days on the front, we are not supposed to write the marks inside. We write the marks only on the upper
On the
sheet.
sheet.
And then that sheet can be scanned and sent to any other person. In case of many time students, they challenge. that I've got less marks. And in the main professional and in here in AIMS Patna, they challenge us during the internal assessment also. So then we send it to any other person, any other resident, and then you can see the probably whether his student is pass or fail or any other if you are using some category. I don't know why this got hang up, this category wise kappa. Let me all and remove. And then I'll again do the analysis. So actually this is taking, in JASP, you can see it again gives you a fleece kappa in all the category with 95% confidence interval. But that pair wise, it doesn't give, but yes, category wise, it is giving you. Overall also, when for thyroid 1, 2, 3, 3F and 4, it gives you the fleece kappa with 95% confidence interval. And here, if I go to the Seoul matrix, use the rater reliability, move these three. And then click on the fleece kappa, confidence interval, category wise kappa, pair wise with the exact kappa. Let's see. Just so it is coming. Gem movie. Yeah, it is coming. It is coming. So is this okay? This it is clear, and this is the same table as shown by the these author in the article. This like they have shown overall as well as the 1, 2, and 3. In this case, the raters were unique, but just to explain you the concept of unique and non-unique rater, we have brought that concept. So you can go to the breakout room and see. I don't know. I'll close this Jamovi and once again open this because. So we are opening the breakout room. Please practice on.
Yes.
Okay. Thank you, Nishi. So now coming to the biases in agreement analysis, which I think Dr. Ravi raised this question in the beginning. So there are, I think, three most common type of biases in agreement analysis. The first bias is like there is a fatigue, you can say fatigue or tiredness towards the end. So the observer might rate these slides or x-rays saying yes to all or no to all. And that can be assessed using the same kappa, but there is an option of intra-observer kappa. And I think in one of the article which we have shared in that radiology femur neck fracture, you read that there was a paucity of time, so that's why we are not discussing. There were three more data set. So we could not discuss those data set, but we have given the files to you people. You can practice that seeing the paper. And in that, all the three group of residents, they were given the same X-rays 1 month later. So it is something like test, retest reliability or the intra-observer. The same set of person is observing the same X-ray after 1 month or 2 months. So that is one bias which we can check using this intra-observer agreement over some period, like let's say 15 days, 1 month, 1.5 months, whatever the objective was. The second is like the objectivity in measurement. So if the classification is not clear cut and you have to train your residents or the observer well in rating those x-rays or histopathological examination or anything. So that training should be there. That can again remove the biases of the subjective versus the objective criteria of judging something. And the third is regarding the prevalence and the rater bias. So there is a prevalence paradox in this agreement. And let's see this one example. So if there is any disorder which is very low in prevalence, suppose let's say here it is tuberculosis, but we have shared one article where they have screened the, I think, urethral or the urethral cancer. So in that case, suppose if we two doctors are examining the same this set of x-ray and Dr. A is saying only there is a consensus on only one patient. That means there's only one person who has been like said yes by both, and there are 91 who has been said no. That means the prevalence of that disorder is only 5%. That out of 100, only 5 is present. So even if like by here, if you see by chance is too high, that means even if the person is only saying no, 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 out of 100, there are chances that he will be correct in 91% of time. So the overall observed agreement is 92%. But if you calculate the Cohen kappa, so the value of Cohen kappa in this case will be 0.158, which is very less because it is imbalance. If you see the marginal, these are known as the marginal table value. If the marginal table values are so much of imbalance, then if you calculate like we have just shown the calculation, the value of Cohen kappa will be very low. Although the observed agreement is 92%, but the value is 0.158. So, which is a very slight agreement. So that's the prevalence paradox, because kappa is very less despite showing a very good percentage agreement. And that's why there is something known as the prevalence adjusted bias adjusted kappa. So how we calculate that prevalence adjusted bias adjusted kappa? This was one article which we have shared. Agreement between the magnetic resonance imaging and ultrasound in the deep pelvic endometriosis. And if you see the paper, there was a perfect agreement for endometrioma or hemorrhagic cyst, almost perfect agreement for bladder involvement, and they have given the value of PABA K. And this PABA K is prevalence adjusted, bias adjusted, kappa. So this prevalence adjusted, bias adjusted kappa, this concept was given by this Trade Bryant, Janet Bishop, and B. Carlin. And they have said that Cohen kappa is, again, it has got few biases, and they have, I have just taken this snip from the appendix. So they have given the formula of this PABA, this prevalence adjusted bias adjusted kappa as 2P0 minus 1. That means twice of observed agreement minus 1, and they have deducted this formula using all these calculations, and they have introduced a separate statistics for bias index and prevalence index, which they have used here. I am not going to tell you the detail of that. Just remember that this is the formula for the prevalence adjusted bias adjusted kappa, that you see the observed agreement, you multiply that by 2 and then deduct 1 from that. So this is calculated by the same formula, 2P0 minus 1. So if the 9.92 is the observed agreement, your prevalence adjusted bias adjusted kappa will be 2 into 0.92 minus 1, which is 0.84. So now just to summarize, in what situations you can use which type of kappa. So if there is an agreement between the two raters and those two raters are the unique raters, then you should use, and if the data type is nominal, you will use the Cohen kappa. If there are two psychologists and they are rating like mild, moderate and severe, which is on the ordinal scale, then you will use the weighted kappa because there are only two raters. But again, if there are more than 3 nurses, then you will use the fleece kappa. And if there are nurses which are using into the, again, if it is an ordinal, then you will use the weighted fleece kappa. Or you can use the Krippendorf, because Krippendorf is again the it's the one place solution for everything. In all the imbalance cases you can use, and if there are like prevalence is very less or very high, then you can use the prevalence adjusted bias adjusted kappa. So this is regarding. Then there are some common misuses of this kappa. So the common misuse of this Cohen kappa is if there is a ordinal data, then you should not use the simple common kappa. You should use the weighted. And again, if there are difference prevalence, then you should use the prevalence adjusted bias adjusted kappa. Fleece kappa, again, the common misuse is if there is a ordinal data, you should use the weighted fleece or you use the Krippendorf. So this is again just the common this thing. Weighted kappa is again the linear and quadratic weight. We have discussed that. What type of weight you should use in the linear and quadratic weight. So this is just the overall summary. of this various types of kappa. So again, I will just show few of the data set which we have shared, since we could not share that analysis, but I will recommend that you please see this femoral neck. Because if you see this femoral neck, we have shared the data set and we have shared the article also. So what about that expert and gold standard? I think one participant was saying Ishan, or I forgot the name. And you can see in this paper, let me. So here in this paper, they have used 6 orthopedic surgeons divided in 3 groups based on trauma experience, evaluated 150 blinded this anterolateral and lateral and anteroposterior FNF using Gardens. 3 classification they use: Garden classification, AO classification, and simplified AO classification. And then 1 month later, the radiograph were renumbered and then each observer performed a second evaluation. This was like intra-observer, which I was telling you. And then kappa statistical were used to determine the reliability of classifications. Cohen kappa was calculated to determine the intra and inter-observer, and Fleece kappa. So they have used, I think, all type of kappa here. So if you come down, I'll just show the table. So this is one table, inter-observer reliability of Garden classification. So these are the 6 people, and here also 6. So this table is same as you see this one, the observer one, which is the pair-wise comparison. This one, Jamovi gives you this table, but in JASP you have to like make it. It doesn't give you this table as an output. Again, if you go, so this is the same. They have like measured the inter-observer, that means pair-wise comparison. And again, this is the inter-observer for the same AO classification, and this is for the simplified AO classification. So all those 3 classification, they have shown this. And this is the group kappa value for the trauma and the junior trauma surgeon. And then this was the intra-observer, which I said, like, this is one way of removing the bias. Intra-observer reliability means the 2 values here are the same observer, but after 1 month. And then they have seen between the Garden and this thing for all these 3 type of classification in all these 3 groups. So this is how you can use the various types of kappa, the Cohen kappa, weighted Cohen kappa, then Fleece kappa, and Krippendorf. So that's it from our end. ICC Bhavna, it is for the continuous data, because if you can recall, all the categorical data. So next workshop is on continuous agreement, where we'll show the ICC and Bland-Altman.
I had a small question, ma'am. If the same rater is rating the participants, let's say today and after 3 months,
Yeah.
Let's say we have 10 patients and the same rater is rating today, and after 3 months the same rater. So ma'am, what kind of agreement analysis will we do?
Same kappa, but it is not inter-observer. It is intra-observer.
Intra-observer.
Yes.
And depending on the number of categories, Fliss or Cohen or anything.
Yeah.
Okay. Thank you.
That is again one use of kappa.
Okay.
Not only between 2, but rather 2 different time point
3 time points
or 1. And again, like if you do it for 3 time point, then it will be the Fleece.
Okay, right. Yeah, so suppose if the same rater is measuring at three time point, then we'll use Fliss instead of Cohen.
Generally, we don't do, but
we
can do that.
We can do that. Thank you.
So I think we'll share the PowerPoint in the folder, recording and certificate. The way I think all of you are our previous participants, I guess so. So you will get a questions and you have to attend that over the Merit India website, and then you can generate the certificate. Recording and the PPT we'll share, and we have shared the data set. So that's it from our end.
Thank you so much, ma'am. As usual, you have been wonderful, ma'am.
Thank you, Dr. Ravi. Thank you so much. And thank you to all participants.
Thank you, ma'am. Thank you so much.
Okay, so we are ending the meeting from our end.